with the cases I've already shown you, we've just had a load of possibilities that loads of outcomes that are equally likely. So you just count up the number of outcomes and then you look out of that which ones suit the condition you like and work it out that way. But obviously that's not always true. So for example, how about if we had a bag of marbles that contains 60% blue marbles and 40% white marbles. So we're going to look at a couple of things, drawing 2 marbles out of the bag. So the first condition is, our first question, so replace, and we're replacing marbles into the bag. That's important. What is the probability of drawing 2 blue marbles? Alright, so let's do our little tree first of all. So we could draw a blue marble or a white marble, and 60% of the time, so 0.6, we'll get a blue one, and 40%, 0.4, we'll get a white one. So that's our first draw. And then the second time, the same thing will happen again. So 0.6 we'll get, we've already got a blue, and then we get another blue. 0.4 we'll get, we've already got a blue, and we'll get a white. We've already got a white. 0.6 we'll get a blue. 0.4 we've already got a white, and we pick the second one to be blue. So that's the second one. So this is where we need to use our equation that we've learned before. So the probability of drawing a blue and a blue is the probability of drawing a blue for the first, plus the times, so we're drawing a blue and a blue, so probability of drawing a blue for the first one times the probability of drawing a blue for the second one. Alright, so we do 0.6 times 0.6, 0.36, so 36% of the time you're going to get these 2 blues. And 0.6 times 0.4, that gives you a blue and then a white, 24% of the time. So that's 0.4 times 0.6. You draw a white and then a blue, also 24% of the time. And then you could draw a white. I'm sorry, I've written this wrong here. This is a white and then a white. 0.4 times 0.4, so that's 0.16. And all of these add up to 1, so this is an exhaustive list. So you're always going to draw a blue and a blue, or a blue and a white, or a white and a blue, or a white and a white. So that's just what I'm showing you here. So the probability of a blue for the first time is 0.6 times the probability of a blue for the second time, which is also 0.6, so that's 0.36. Now how about the probability of one white and one blue in any order? So that is the probability. So here, that's these guys, so that's 48% of the time. We can see that from our probability tree, but we could write it out like this instead. So that's the probability of, so a blue and a white. So that's the probability of drawing a blue first times the probability of a white second. So that is a blue and then a white, plus the probability of drawing a white and then a blue. So that would be white first times blue second. Okay, so this is the probability of drawing a blue and then a white, plus the probability of drawing a white and then a blue. So that would be 0.6 times 0.4 plus 0.4 times 0.6. So this is just the same as was happening up here. So that's 0.24 plus 0.24 or 0.48. So those are a couple of examples to show you the way to use probability trees and equations to work out probabilities when the outcomes are not equally likely. It's no harder really than if they are equally likely.